Hi friends, see in before chapters in ray optics, we have completed up to part 4. Okay, now today in ray optics we will be going to part 5. Okay, that is in part 4 we have dealt about shift regarding a glass slab, that is T is equal to S is equal to T into 1 minus 1 by mu in normal cases, and in, for example, the surroundings without air, if surrounding is there, then the shift is given by T into 1 minus mu surrounding value by mu slab. And if S value, shift value is positive, the direction is along the direction of incident light, and if shift is negative value, it is against the incident light direction. Now today's class will be little faster. We will be dealing about critical angle గురించి తెలుసుకుందాం. Critical angle C and thereby TIR, total internal reflection. We will be dealing about total internal reflection. So critical angle ante enti? Part 5 this is, because I told you in the beginning only, it is very lengthier chapter, big chapter, light ray optics. So critical angle ante enti okasari chuddam. See, I told you in before topics, for example, this is first medium, refractive index mu1, second medium, this is air, rarer medium, and this is denser medium other than air, like water or whatever thing, glass plate, like water or glass plate, and of course mu2 is greater than mu1. Optical, it is denser. Now for example, please make a note, suppose this is the incident light, say I1. Now this is normal, this is the surface separating the two medias. Now light will be refracting as R1. Now same fashion, if I increase the light direction, incident light angle, now I2, the refraction angle also increases, R2. Again, if I go on increasing this value I3, the refraction angle also go on increasing. But at a point comes, if the angle of incidence in the denser medium, happens to be C, then what happens at a particular instant? The light will be making 90 degrees with the normal. That means it is grazing the surface. And if I is equal to C, if the incident angle in the denser medium is equal to critical angle incidence, then the light, what happened? No more refraction. And if I is less than C, incident angle in the denser medium is less than C, critical angle, then it is refracting. If it is equal to C, you can see it is grazing the surface, making 90 degrees with the normal. In the same fashion, if I go on increasing more than C, inka angle of incidence, suppose if I increase the angle of incidence more than C, critical angle, then the light again comes back, okay, as R. Therefore again, from laws of reflection, angle I is equal to angle R. This phenomenon of light is called as total internal reflection, TIR. Then emantaru manam total internal reflection ante, if the main things you have to remember in your brain, if the light is incidenting in the denser medium, if incident angle is equal to C, first of all, it is less than C, light is refracting. C means critical angle. Okay. Now what is critical angle? The angle of incidence in the denser medium for which the refraction angle in the rarer medium is 90 degrees with the normal or grazing the surface. That is critical angle. And if I is equal to C, the grazing the surface, light. If I is greater than C, no more refraction, no more grazing. Again light comes back into the same medium. That phenomenon is called as total internal reflection. Please draw the figure. Very, very important regarding the examination. Okay. These 3 points మీరు గుర్తుపెట్టుకోవాలి mind లోని. Very, very important points, these 3. Okay. If I is less than C, light is refracting. Okay, refracting in the rarer. Equal to C, grazing the surface. Greater than C, total internal reflection. Okay. So in this fashion, the total internal reflection takes place when the light is going from denser to rarer, not from rarer to denser. Okay. ఆల్వేస్ ఫ్రమ్ డెన్సర్ నుంచి రేరర్కి వెళ్తున్నప్పుడు మాత్రమే టీఏర్ అవుతుంది. రేరర్ నుంచి డెన్సర్కి వచ్చినప్పుడు అవే అవకాశం లేదు. బికాస్ డెన్సర్ మీడియం is optically more denser, light goes, what happens, away from the normal. So when it is going away and away, finally it is reaching. అదే రేరర్ నుంచి డెన్సర్ వచ్చినప్పుడు టువర్డ్స్ అవుతుంది. బికాస్ ఏమవుతుంది, రేరర్ నుంచి డెన్సర్, రేరర్ ఈజ్ లైటర్ మీడియం, డెన్సర్ ఈజ్ హెవియర్ మీడియం. మీకు అర్థమవుతుందా? చూడండి, ఇది డెన్సర్ మీడియం, డెన్సర్ నుంచి రేరర్ ఏమవుతుంది, అవే వెళ్తుంది నార్మల్కి, అవే యూ కెన్ సీ అవే. సో ఫైనలీ ఇట్ ఈస్ కమింగ్ బ్యాక్. అదవుతుందా? అదే ఫర్ ఎగ్జాంపుల్ చూడండి, ఇది రేరర్ అనుకోండి, ఇది డెన్సర్ అనుకోండి. రేరర్ అయితే లైటర్ మీడియం, లైటర్ మీడియం ఎంటర్ అయినప్పుడు ఏమవుతుంది, ఇట్ ఈస్ మోర్ డెన్సర్, అప్పుడు ఏమవుతుంది, టువర్డ్స్ ద నార్మల్ వెళ్తుంది, టువర్డ్స్ ద నార్మల్. సో దేర్ ఈస్ లెస్ ఛాన్సెస్ ఫర్ రేరర్ టు డెన్సర్ వెళ్ళినప్పుడు టోటల్ ఇంటల్ రిఫ్లెక్షన్. But from denser to rarer, because it is heavy, optically heavier, it goes away from the normal. Okay? It goes away. Finally, it reaches the target, that is TAR. Now, let us go further in this chapter, total internal reflection. That is, we'll see a formula for critical angle. Critical angle formula ఏంటో ఒకసారి చూద్దాం. Formula for critical angle, that is C. చూడండి ఒకసారి, this is the normal NM, this is the surface PQ separating medium 1, medium 2, first medium rarer, you can take it as air, second medium denser, and of course mu2 is greater than mu1. Denser అంటే మీ ఇష్టం, you can take other than air like fluid, water, glass, anything. Okay, now suppose light is entering in this fashion angle, and for example for this, let the grazing the surface with the normal be 90 degrees. Now apply here at this point Snell's law. Apply Snell's law. Already in the before topics I told you Snell's law. Entadi sin angle incidence into this media refractive index, sin angle refraction into this media refractive index. So sin angle incidence, okay, into this media into refractive index mu2 is equal to sin angle incidence ఎంత అక్కడ I is equal to C కదా అనుకున్నాం. సో put C here, sin angle incidence I is equal to C కదా, incident angle, denser medium, into refractive index of this medium is equal to sin angle refraction. Refraction ఎంత R, it is making 90 kada. So R you can put 90 degrees. R you can put 90 degrees. Sin angle refraction into the refractive index of this medium, and the mu1. Okay. Now what happens? You see the formula sin C into mu2 is equal to sin 91 from your trigonometry into mu1, or I can get sin C is equal to mu1 by mu2, or sin C. This one, what is mu1 by mu2? I can write in this fashion. Mu1 like this, and refractive index of the first medium with respect to 2, and also I can write like this also, 1 by mu2 by mu1 could write, because it goes to the top again, it becomes mu1 by mu2. And అర్థం ఏంటి, the sin C critical angle is nothing but 1 by mu2 with respect to 1, refractive index of second media with respect to 1, the refractive index of first media with respect to 1 right. Clear? And not only this, sin C is always given by mu of rarer by mu of denser. Therefore sin C, mu of rarer medium air అనుకుందా 1 by mu of denser medium mu10 andaka, let us consider as mu2 let us consider as mu. Then what happens, this is the main formula, sin C is given by mu of rarer, refractive index of the rarer medium, by refractive index of denser medium. So 1 by, let mu2 is equal to 1. So this is the formula you will be adapting for numericals. Sin C is equal to 1 by mu, or mu is equal to 1 by sin C, or mu is equal to 1 by sin C, where mu is the refractive index of the media 2, second medium, C is the critical angle. C is the critical angle. Please note down. This is very, very important formula. Very, very important. Please note down. Okay, clear? So this is the main formula for critical angle. Meeku adavutunda? And one more thing you have to note down. The sin C is always less than 1. Okay? It cannot be greater than 1, sin C. Because sin 90 is 1. Maximum value sin 90 1 మన trigonometry నుంచి. So sin C is less than 1. Maximum. Okay? Maximum sin C value is always less than 1. Now let us go still further in this one regarding examination point of view. Now what I will do is we will try to do some 1 or 2 numericals for this Snell's law. Okay. Are you following, all of you? ఇది చాలా చాలా ఇంపార్టెంట్ అండి ఎగ్జామినేషన్లో రెగ్యులర్గా వస్తున్నాయి పరీక్షల్లో. Now let us see the things numericals. న్యూమరికల్లో ఫర్ ఎగ్జాంపుల్ ఫస్ట్ న్యూమరికల్ చూద్దాం ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ. ఫర్ ఎగ్జాంపుల్ ఐఎమ్ గివింగ్ యూ ఎ ఫిగర్ that this is 90 degrees. Okay. For example, this is some surface, glass surface, some glass surface. Now let the angle of incidence be like this. Okay. Let they are given this angle as 42 degrees. Let the angle is given as 42 degrees. This is a glass type material. Okay. And the angle of incident is given as 42 degrees. I is given as 42 initially. And critical angle in this case is given as, see, critical angle is given as, okay, 42 degrees. Critical angle kuda 42 degrees icharu deeniki. Okay. Critical angle ante telusu kada, when I is equal to C, the light grazing the surface. Less than C refracts. Greater than C, it reflects, total internal reflection. So we will check up whether what happens and we will find out what is the final path. What is the final path? That means when light is entering in this fashion, we will see what happens. Will it graze the surface or reflects or refracts or what happens? We will see. So make light incident and drawing normal. This is the normal. See, I told you this chapter dealing with geometry, maths geometry. So this is the normal. Draw a normal. So this angle is 90 degrees. So what will be this angle? 90 minus 40, that is 48 degrees. Just చూడండి. ఓకేనా? So you can't take this one with surface. ఎప్పుడు కూడా angle of incidence దేంతో ఉండాలి? With normal. So if total angle is 90, angle ఎంత ఇచ్చాడు మనకి? 42 ఇచ్చాడు initial. This is the wrong one. This is the angle of incidence, 48. Now check up. I is greater than 42. Angle of incidence is greater than 42. So what happens? It reflects. Okay. So it will be reflecting. Okay. You can see the light will again reflect. ఎంత angle తో వెళ్ళిందో it will reflect according to our principle. With okay, again what angle? 48 degrees, because from laws of reflection, I is equal to angle, I is equal to angle R. So again this angle is 48. If this angle is 48, again ఇదంతా 90 కదా, మళ్ళీ ఇది ఎంత అవుతుంది? Geometry 42 degrees. ఇది 42, ఇది 90 అయినప్పుడు ఇది ఎంత అవ్వాలి? ఇది 90, ఇది 42, మళ్ళీ ఇది 48. Because 90, 42, 48, 180 degrees. So here it is incidenting now. Now again draw a normal. One more normal. Now this is not the angle of incidence because this is surface. So this is the angle of incidence now again here. అప్పుడు ఈ యాంగిల్ ఎంత అవుతుంది మళ్ళీ? Total 90 minus 48, again 42. So you can see finally when it is reaching this one, I is how much? 42 degrees. That means you can see here angle of incidence is equal to critical angle. So I told you in the before last 20 minutes back, when angle of incidence is equal to critical angle, what happened? This light ray will grazing the surface. You can see it is making 90 degrees with the normal. Chudandi. It makes 90 degrees with the normal. This is denser medium. This is rarer medium. Entering, grazing the surface. So you can see this is the final path. Grazing the surface. So this is how you have to solve the problems. Okay. Please note down, very, very important this problem numerical. So as I told you, ray optics is mainly dealing with the geometry. That is why it is also called as geometrical optics. That is why it is also called as geometrical optics. Clear? Shall we do one more problem? Inko problem try cheddam manam. Okay. One more problem we'll try. See here. Suppose the triangle is given in this fashion, ABC. AB, so triangle icharu. And they are given some angles also, 30, 60. 30 degrees, 60. Therefore, this will be 90. And in this case, the angle is incidenting in this fashion, it seems. Okay. That is, it is going normally. Straight ga veltundi. And it is hinting like this in this fashion at this point. Now, for example, when the light is coming like this, light, incident angle. This is 30, this is 90. So what will be this angle? Again, 60 degrees. Now for here, you will draw a normal. So this is normal. So this is 90. It is 60. Up to the 30. So 30 degrees here is the incident angle. Now check up. దీనికి మీకు ఆల్రెడీ దీనికి కూడా మీకు క్రిటికల్ యాంగిల్ ఇచ్చాడండి. సి 42 degrees ఇచ్చాడు. క్రిటికల్ యాంగిల్ is given 42. Check up. So I is what? 30 degrees ఇక్కడ వచ్చింది. That means I is less than critical angle. So what happens here? When I is less than critical angle ఏమవుతుంది? Refracts. I is equal to C, grazing. Greater than C, reflects. TAR. So ఇదేమో less than C కాబట్టి it will be going outside light. అంటే this is denser medium కదా. ఇది denser medium. ఇది rarer medium. So when light is entering, what happens? This is normal. Okay. I is less than C కాబట్టి denser నుంచి rarer గా ఏమవుతుంది? It goes away from the normal. It goes away from the normal. Now how to get that one? Apply Snell's law. At this point of incident, applying Snell's law. So how will apply here? Sine angle incidence. Sine angle incidence into refractive index of this one. Glass refractive index ఎంత ఇచ్చాడు మీకు? 3/2. Okay. 3/2 is given glass. Glass is 3/2. So into 3/2 is equal to sine angle refraction. That is sin R into refractive index outside 8. That is 1. Therefore sin 30 half into 3/4. 3/2 is equal to sin R, or 3/4 is equal to sin R, or R is equal to sin inverse. You can write clearly 3/2. Okay, or R is equal to sin inverse 3/4. And this value I think nearly around 49 degrees. And then 49 degrees. So clear? So what is the refraction angle? R is equal to sin R is equal to 3/4. Already it is given in the problem. That is sin inverse 3/4 is equal to R. So the angle is 49 degrees. So that is the answer. Okay. So finally light ray, what happens? It refracts because I is less than critical angle. If it is equal to grazing greater, it reflects. So answer is 49 degrees refraction angle. Okay. So this is how you have to calculate the numericals by using Snell's law and the theory. Now let us go to the next item. Very, very important this one. I told you it's a very big chapter. It is not yet completed. Almost it is 5th part in ray optics till today. Now let us go to the next one. Circle of illumination. Next item enti? Circle of illumination. Now we will study what is circle of illumination. ఇదేంటంటే, for example, consider here one small bulb. Okay. So this is, let is normal. So bulb is illuminating some light. Okay, I'll take this as a surface. Okay. Now this is the normal incidence. And from here, and make a note, this is some medium, denser medium, and this is rarer. Rarer, either you can take air, denser other than air like water or whatever thing can take. Okay. Now when light is incidenting like this is normal angle of incidence. So denser nunchi rarer ki light emutundi, goes away. In the same way, again normal, I1, I2, R1 goes away. You can see gradually R refraction angle is increasing, you can see I3. So what happens at a particular time? See, at a particular time when I is equal to C, it is grazing the surface. Less than C varaku it is reflecting. See, refracting. When I is less than C, it is refracting. This is refraction. Refraction of light. When I is equal to C, it is grazing. But if you go on increasing, what happens? Again, light will come back. This is called as total internal reflection. In the same way, you can see here, this is a normal angle of incidence, refracting. Okay. Same way, normal. Okay, refracting. Normal, refracting, and grazing at a particular instance. Finally, again it reflects. So if you observe carefully, this is the circle of illumination, and this is the radius. So when you see from the top, this is the portion circle. So when the light is illuminated in this fashion, the top portion, that is called as circle of illumination, from denser to rarer. Okay. So in this figure, if you observe carefully, see here, this is circle of illumination. Okay, and this is your radius, and let this one be height. Let this be height. Okay. Now you see, I'll extend this line. This is a normal. So this is angle of incidence kadadi. ఇక అక్కడి నుంచి మనకి రీఫ్రాక్షన్ స్టార్ట్ అయ్యి గ్రేజ్ అయ్యి మళ్ళీ కిందకు వచ్చేస్తుంది. మళ్ళీ ఇక్కడ కూడా ఐ డ్రా వన్ నార్మల్ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్. ఓకే, రీఫ్రాక్ట్స్, గ్రేజింగ్ అండ్ కమ్ బ్యాక్. సో ఇఫ్ దిస్ యాంగిల్ ఈజ్ ఐ, ఫ్రమ్ జామెట్రీ దిస్ యాంగిల్ ఆల్సో ఐ. సో వాట్ ఐఎమ్ ట్రైయింగ్ టు టెల్ ఈస్, ఫ్రమ్ దిస్ వాట్ ఈస్ tan theta? So I'll write it here. From this, what is tan theta or tan I? Tan I is equal to opposite by its end, that is R by H, or R is equal to H into tan I. Are you following the point here? R is equal to, because this is the angle of incidence. కానీ ఇక్కడ పాయింట్ గుర్తుపెట్టుకోవాలి మీరు. See, the angle of incidence పెరిగే కొద్ది రీఫ్రాక్షన్ అవుతుంది. ఎక్కడ ఇది గ్రేజ్ అవుతుంది? when I is equal to C. When I is equal to C, it is grazing. ఓకేనా? ఇక్కడ వరకు రీఫ్రాక్షన్ అవుతుంది. When I is happens to be C, it is grazing the surface. And for angle of incidence, the critical angle is equal to the angle of incidence. For that it is grazing, and then after that it is, when you increase the angle of incidence, it is again coming back. Are you following the point here? So here what is I here? C. I is equal to C. When I is equal to C, therefore R is equal to H into tan C. మీకు అర్థమవుతుందా పాయింట్? యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ లెస్ దెన్ వరకు సి వరకు ఉన్నప్పుడు రీఫ్రాక్ట్ అవుతుంది. ఓకేనా? అక్కడ వరకు కోన్ ఫామ్ అయింది, దాని తర్వాత గ్రేజ్ అయిపోయింది, ఇంక ఎండ్ అయిపోయింది. దెన్ అగైన్ ఇట్ ఇస్ కమింగ్ బ్యాక్. దేర్ఫోర్ when I is equal to C here, when I is equal to C. From this what happened? Tan C. From here what happens? I బదులు tan C is equal to opposite by this end. Or from this what happened? What is R? H tan C. Radius of the ఈ కోన్ ఎంత అయింది? H into tan C. Now you can calculate tan C also by using geometry. What is sin C? Critical angle. Mu rarer by mu denser medium. So sin C, mu rarer ఎంత? Air 1 అనుకుందాం. Denser mu 2ని 1 అనుకుందాం. 1 mu అనుకుందాం. As before, what you have assumed. So from that what happens? Sin C is equal to 1 by V. I'll rub this one. Now, from that, what is sin C? Mu rarer by mu denser kada. So what you got the value here? So from that, what is sin C? I'll draw a triangle here. Sin C ఎంత అవుతుంది? Opposite by hypotenuse. Opposite by hypotenuse. What is this value adjacent? Root over mu square minus 1 is equal to this side. So root over mu square minus 1. So from this I can get tan C. So R is equal to H into what is tan? Opposite by adjacent, that is 1 by root over mu square minus 1, which is equal to H by root over mu square minus 1. This is the radius of the illumination cone. That is the radius. And from that, how much area it is illuminated? Circle of illumination. You can calculate. What is the area of a circle? Area is equal to pi r square. So A is equal to pi into, what is radius I got? H by root over mu square minus 1 whole square. Therefore pi into square cheste h square by mu square minus 1. This is the area of illumination of the light. So this is how the MSET problems and NEET problems are solved regarding a circle of illumination. Please make a note. These are very, very important in solving numericals. Clear? Okay. Now, let us go still further into the subject. It is interesting, I think. Okay? Is the subject interesting? Part 5. Right. Now, after completing the circle of illumination, we'll go for applications of TIR. Applications of total internal reflection. So very first one application ఏంటంటే ఇది జనరల్గా మనం చూస్తూనే ఉంటాం ప్రాక్టికల్గా. దట్ ఈస్ in desert areas, okay, mirages are formed. దీని తెలుగులో ఎండమావులు అంటారు. ఎండమావులు అంటే ఒక ఎడారిలో అలా నడుచుకుంటూ వెళ్తున్నప్పుడు మీరు చాలాసార్లు మనం మోసపోతుంటాం. ఎడారిలే కాదు, ఈవెన్ ఇన్ అవర్ ప్లేసెస్ మిడ్ సమ్మర్ అంటే 12 o'clock ఆ టైంలో వెన్ యూర్ గోయింగ్ ఆన్ అ బైక్ ఆర్ కార్ ఆల్సో సడన్లీ యూ కెన్ సీ ఆన్ ద రోడ్ వాటర్ విల్ బీ దేర్. రియల్లీ ఇట్ ఈస్ నాట్ ఎ వాటర్, ఇట్ ఈస్ ఎ ఫేక్ వాటర్. ఇట్ ఈస్ డ్యూ టు TIR. నిజంగా అక్కడ వాటర్ ఉండదు రోడ్డు మీద. బికాస్ ఆఫ్ ద వెన్ లైట్ ట్రావెలింగ్ ఫ్రమ్ డెన్సర్ టు రేరర్, దిస్ ఫినామినన్ దట్ ఈస్ వెన్ ఐ ఈస్ గ్రేటర్ దెన్ సి ఇన్సిడెంట్ యాంగిల్, క్రిటికల్ యాంగిల్ కన్నా ఎక్కువ అయినప్పుడు the light reflects back once again, and thereby due to that phenomenon it appears that water is present. So in desert areas mirages are formed. Mirages and neeru unnattu అనిపిస్తుంది, water. Okay, mirages formed, that means it appears water is there but water will not be there. This is the main total internal reflection application. రెండవది optical fibers లో. So nowadays you can see optical fibers are mainly used in the cable connections, and this optical fiber, if you observe carefully, it will have two parts mainly, that is cladding. This outer part is called as cladding. Okay, this outer part, ఈ బయట part ni cladding అంటారు. This in this inside part called as inner light guiding core. And this refractive index is greater than outside one. అంటే క్లాడింగ్ కన్నా దీని రిఫ్రాక్టివ్ ఇండెక్స్ కొంచెం ఎక్కువ ఉంటుంది. సపోజ్ ఇది 1.6 అనుకోండి, ఇది 1.7 నియర్లీ. సపోజ్ క్లాడింగ్ అవుట్ సైడ్ ఈజ్ 1.6, ఇన్సైడ్ లైట్ గైడింగ్ కోర్ mu2 will be little more, like 1.7, like that roughly. So inside light guiding core, the refractive index is more than outside. So when light enters, it's called a launching angle. First it refracts, okay, and then again what happens, this cladding will not allow to go outside. It is protected in such a way. So again it comes back. Again, if you draw normal, again cladding protects, goes. So like this, continuous reflections will take place in the optical fibers. And please make a note, these optical fibers are nowadays they are using. It is less weight but costlier. Because ఇప్పుడు పాత కేబుల్ వైర్ చూస్తే కొంచెం లావుగా ఉండే, హెవీగా ఉండే. But these are lightweight and minimum energy loss will be, and maximum energy is used in this one. Because almost it travels to the velocity of light, with the speed of velocity of light. So in the why nowadays optical fibers are used is because minimum energy loss, maximum energy used, and total internal reflection takes place in this one. Not only here, in medicine also optical fibers are widely used. For example, if anything happens inside our body, for using, for diagnosis purpose, they will be sending that pipe with some small camera, and inside if anything is happening like gastroenterology and other things, these optical fibers also used to detect if any intestines, any problems are there in stomach. So like that in medicine also, in diagnosis purpose, optical fibers are widely used. Please make a note, these are costlier than normal cable wires and it is less weight. Clear? Right. Let us go to the next one. So these are the main applications of optical fibers. Examination, they will be asking 1 or 2 marks questions. Now, next item, let us go to the prism. Next one is prism. Okay? We'll see what is meant by a prism. Prism means it is nothing but a solid like triangle. Okay? It's made up of glass material, special glass material, solid like triangle, and it is equal to 60 degrees angle, almost equal triangle model తయారు చేస్తారు. The angle is almost equal to 60 degrees maximum. Now in the prism, if you observe, suppose this is the light entering, incident light, this is the normal, this is called as the angle of incidence. Now when light enters from rarer to denser, this is glass material, ఏమవుతుంది, it goes towards the normal. Okay, it goes towards, this is called as refraction angle 1. Again meeting normal, again normal 2, this is normal 1. From denser, this is refraction 2, it goes away when goes to the rarer medium again. So this is emergent angle I2, or sometimes it is also taken as E. I2 ni E kuda anochu, this is emergent angle. Suppose actually if this medium is not there, this light will has to go like this. Idi kuda ante, extend this line. When you extend this line, they will meet at this point, A, B, C, D, E, F, and if you extend this line also, it will meet at G. So in the examination, they will be asking what is these angles and what is this angle, minimum deviation angle. Okay? So this derivation also, it is very easy. You will be getting this equation, mu is equal to sine of A plus dm by 2 by sine A by 2. By using Snell's law. By using Snell's law, you can derive this equation very easily and by using a graph. So here if you observe carefully, చూడండి, this angle is equal to this angle. So what is this angle? I1 minus R1. In the same way, this angle is equal to this angle. What is this angle? I2. I2 minus R2. And this angle plus this angle is equal to exterior angle, that is minimum deviation angle. So finally what happens? I1 plus I2 minus of R1 plus R2 is equal to dm. The dm is called as minimum deviation angle. And here you can see this quadrilateral ADGE. ADGE is a quadrilateral. In a quadrilateral, the sum of interior angles is equal to 360. You can see sum of the interior angles, that is A, D, G, A. D you can say 90 degrees, E also 90, and this angle, these two, you can calculate. ఎలాగా చూడండి ఇక్కడ ఈ ట్రయాంగిల్ ఆల్రెడీ మనం ఇది క్యాలిక్యులేట్ చేసుకోవచ్చు కదా. ఇది ఎంత అవుతుంది చెప్పండి, ఇది R1 ఇది R2 కదా, ఎంత అవుతుంది అప్పుడు ఇది యాంగిల్ G I can calculate 180 minus R1 plus R2 అంతే కదా జామెట్రీ. ఈ యాంగిల్ ఎంత అవుతుంది 180 minus R1 plus R2 ఈ యాంగిల్. సో నౌ సబ్స్టిట్యూట్ హియర్ దిస్ యాంగిల్ ఎంత 90, ఇది 90, ఇది 180 minus R1 plus R2 plus angle A is equal to 360 degrees అంతే కదా. Angle A plus angle D plus angle G plus angle F E is equal to 360. Angle A, angle D 90, angle G 180 minus R1. Just చూడు 90 plus 90 180, 180 plus 180 360, 360 and this one will be cancelled. What is left over? Take this one to the other side. A is equal to R1 plus R2 equation 2. So this if you put it here, what happens? Minimum deviation angle ఎంత అవుతుంది I1 plus I2 minus of R1 plus R2లో A అవుతుంది. A is equal to DM. లేదా I1 plus I2 is equal to A plus DM. Clear? Now what happens is in this case, we'll try to draw some graph. ఇది మీకు యాక్చువల్గా ఐపీలో అయితే గ్రాఫ్ ఉంటుంది, ప్రాక్టికల్స్ కూడా ఉంటాయి మీకు. ఆ గ్రాఫ్ కూడా ఎలా ఉంటుంది అంటే ఒకసారి చూడండి. ద గ్రాఫ్ విల్ బి ఇన్ దిస్ ఫ్యాషన్. See on x-axis all incident angles on x-axis, and on y-axis deviation angles are taken. A graph kuda ela untadante you can see first it is decreasing and then increasing. Graph values if you observe carefully, first it decreases as the incident angle increases, but again it increases. That means if you observe carefully here, at this point of I, this is called as minimum deviation angle. జాగ్రత్త అబ్జర్వ్ చేయండి. At this point of incidence I, it is called, అంటే what happens at that point, I1 is equal to I2, R1 will be equal to R2. So when you substitute, what happens here, when I1 is equal to I2, ఇది ఎంత అవుతుంది అప్పుడు 2I is equal to A plus DM, I is equal to A plus DM by 2. అలాగే ఇందా మనకు ఈక్వేషన్ వచ్చింది చూసారు మీరు, ఏంటది ట్రయాంగిల్లోని. సో ఐ విల్ డ్రా హియర్. అది R1 ప్లస్ R2 ఇందాక ఇచ్చాను ట్రయాంగిల్లో మీకు. R1 ప్లస్ R2 ఈజ్ ఈక్వల్ టు ఏ అన్నాను కదా. R1 ప్లస్ R2 ఈజ్ ఈక్వల్ టు ఏ, వి హావ్ డెరైవ్డ్ జస్ట్ నౌ. అప్పుడు ఇందులోంచి 2R ఎంత అవుతుంది A. సో వాట్ ఈజ్ R? A by 2. సో ఫైనల్ అప్లై స్నెల్స్ లా. వాట్ ఈస్ స్నెల్స్ లా? sin I by sin R is equal to constant లేదా mu. sin I అంటే A plus dm by 2 by sin R. R అంటే ఎంత వచ్చింది ఇక్కడ 2R, R A by 2 వచ్చిందా డెరివేషన్, which is equal to mu. So this is how you will get the refractive index of the prism. And please make a note, in our syllabus the prism is very small. ఇంత ప్రిజం ఉండదు, వెరీ స్మాల్. ఇట్ ఈస్ వెరీ స్మాల్ ప్రిజం. మీకు కనిపించినంత కాదు, ఇంత చిన్న ప్రిజము. ఓకేనా, అందుకే యాంగిల్స్ కూడా చిన్నగా తీసుకుంటాం. చూపిస్తాను మీకు అక్కడ. అవి కాపీ. సో ఇన్ అవర్ కేస్ వాట్ హ్యాపెన్స్, వాట్ ఎవర్ ప్రిజమ్స్ వీఆర్ యూజింగ్ ఈజ్ వెరీ స్మాల్ ప్రిజం. Whatever prism we are using is very small prism. Then what happens? Sin theta can be equal to theta. when the angle is very small, sin theta can be equal to theta. అప్పుడు ఎంత అవుతుంది? a plus dm by 2 by a by 2 is equal to mu, or a plus dm 2 cancel by a is equal to mu, or 1 plus dm by a is equal to mu, or minimum deviation a by a is equal to mu minus 1, or minimum deviation is equal to a into mu minus 1. This formula is very important for different colors when the examination they give. dm is minimum deviation angle, a is the angle of prism, and mu is the refractive index of the given color. It may be yellow color or Vibgyor, violet, indigo, blue, orange, green, red in spectrum formed by using the prism. Okay, na? So you can apply this formula and you can calculate the minimum deviation angle. A is angle of the prism, mu is refractive index, and remaining all you can apply in that one. Please make a note, in this the prism is very thin prism, therefore sine angles can be equal to the value. So dm is equal to a into mu minus 1. Here a is the angle of prism. So this is how we will be calculating the prism. Now let us go to the next one, that is called as refraction from spherical surfaces. ఒక్కోసారి మనకి చూడండి, refraction from spherical surfaces అంటే అర్థం ఏంటి? సపోజ్ ఒక గ్లాస్ సర్ఫేస్ ఉందండి మనకి. Suppose this is a glass surface and this is the center point. This is for example here, okay, and this is glass material or glass surface. Okay, somewhere you have some object, okay. Oh, so in such cases what happens? For example, object kuda konta distance lo undanukunnam, it is meeting the surface, okay, and this surface of course it will be having some, this sphere kada, din center ekkada untadi, somewhere over here it will be the center, okay. This is the center of this sphere, center, and radius will be this side, okay na. So with this, suppose if you draw normal, okay na, when you draw normal to that one, what happens? అది సెంటర్, ఇది సెంటర్. నార్మల్ మామూలుగా డ్రా చేసుకోవచ్చు మీరు, ఓకేనా. గ్లాస్ సర్ఫేస్కి మీట్ అవుతున్నప్పుడు ఇఫ్ యూ డ్రా నార్మల్, దట్ ఈస్ సెంటర్ ప్లీజ్, దిస్ ఈస్ సెంటర్ పాయింట్, అండ్ ఫర్ దిస్ గ్లాస్ ఇఫ్ యూ డ్రా నార్మల్, light enters from rarer to denser, it goes towards the normal. So light will be going towards the normal. Somewhere over here image is formed, okay. So ee vidhanga if you take the figure, okay, and this is the angle of incidence, that is the angle of incidence, okay. And you know from laws of refraction, angle of incidence is equal to angle of refraction, that theta is equal to this theta, and by using geometry, because the whatever point here, pole P or whatever optic center, you can take this one as P dash, and by using the geometry finally you will be getting the value as like this, n2 by v minus n1 by u is equal to n2 minus n1 by r, where r is radius of curvature of this spherical surface. మీకు అర్థమవుతుందా? ఇది ఆబ్జెక్ట్ డిస్టెన్స్ అండి, ఇది దిస్ ఇస్ ఆబ్జెక్ట్ డిస్టెన్స్. ఆల్వేస్ ఇట్ ఈస్ క్యాలిక్యులేట్ ఫ్రమ్ ద పోల్. మిరర్స్కి అయితే పోల్, లెన్సెస్కి అయితే ఆప్టిక్ సెంటర్, ఆల్వేస్ ఫ్రమ్ ద పోల్ ఆర్ ఫ్రమ్ ద ఆప్టిక్ సెంటర్. దిస్ ఈస్ ద ఇమేజ్ డిస్టెన్స్, దిస్ ఈస్ ద ఇమేజ్ డిస్టెన్స్. If v is image distance, u is object distance, and for example this is n1 refractive index and surface refractive index is n2, then this formula holds good. Entadi n2 by v minus n1 by u is equal to n2 minus n1 by r. R is radius of curvature of the spherical surface, and n1 and n2 are the refractive indices of the outside medium air, and n2 is the inside glass medium. Clear? Okay. So by using this formula also you can solve some numericals. Okay. Now let us go to the next one, that is different types of lenses. Different types of lenses. Different types of lenses. So in general we have convex and concave. This is convex and this is concave. Only convex lo you have again varieties, and please make a note, convex lo idi R1, idi R2, and which is R1, which is firstly incidenting the light. ఏదైతే మొదట లైట్ రేస్ ఇన్సిడెంట్ అవుతుంది దట్ ఈస్ టేకెన్ as R1, and second one is R2, radius of curvature. అలాగే this is R1 and this is R2, and this center point is called the optic center. Mirrors lo మీకు చెప్పాను, mirrors lo pole and in lenses it is optic center. Now again convex lenses lo kuda variety ఉన్నాయండి. See, in convex lens you can observe at the center it is thick. At the center it is thick and at the edges it is thin. Concave lo enti edges thick, edges దగ్గర thick, center దగ్గర thin గా ఉంటాయి. ఓకేనా? సో కాన్వెక్స్ లో మన రకాలు ఏంటంటే ఫర్ ఎగ్జాంపుల్ ఎగ్జాక్ట్లీ రెండు సేమ్ గా ఉన్నాయి, R1 and R2. Then it is called as equiconvex lens or biconvex lens. Equiconvex lens or biconvex. అదే విధంగా ఫర్ ఎగ్జాంపుల్ ఇట్ ఇస్ కట్ లైక్ దిస్, ఎగ్జాక్ట్ సెంటర్ అంటే అలాగే ఈ విధంగా, either in this fashion or in this fashion. This is called as plano-convex lens. Plano-convex lens. Okay na? Next variety చూద్దాం. ఇందులోనే ఇదేంటి చూడండి, దిస్ ఈజ్ ఆల్సో కాల్డ్, చూడండి ఇక్కడ కాన్కేవ్ ఉంది, కాన్వెక్స్ ఉంది. దిస్ ఈజ్ కాన్కేవ్, కాన్వెక్స్ ఉంది. సో ఇట్ ఈస్ ఆల్సో కాల్డ్ యాజ్ concavo convex lens. Even though it is naming as concavo convex, you can see maximum it is convex. Therefore its final behavior is like a convex lens because convex is a converging. Okay, so final behavior is like convex lens only. So that is why it is called as concavo convex. Concavo convex అన్నామని వేరే పేరు పెట్టకూడదు. కాన్కేవ్ అంటే ఇక్కడ ఒక కొంచెం కాన్కేవ్ ఎక్కువ కాన్వెక్స్ ఉంది. సో మేజర్గా ఇట్ బిహేవ్స్ లైక్ ఏ కాన్వెక్స్ లెన్స్ ఓన్లీ. మేజర్లీ ఇట్ ఈస్ బిహేవింగ్ లైక్ ఏ కాన్వెక్స్ లెన్స్ ఓన్లీ. ఓకేనా? నెక్స్ట్ వెరైటీ కమింగ్ టు ద కాన్కేవ్, ప్లీజ్ నోట్ డౌన్. లెట్ us go to the next one. Concave వెళ్ళిపోదాం. These are different types of lenses you have to study in the examination they are asking. Now concave లో వెరైటీ చూద్దాం. కాన్కేవ్ లో వెరైటీస్. కాన్కేవ్ ఇందా చెప్పాను కదా, థిన్ ఎట్ ద ఎడ్జెస్, థిక్ ఎట్ ద మిడిల్. ఇది ఆప్టిక్ సెంటర్. ఇది ఈక్వి ఆర్ బైకాన్కేవ్ లెన్స్. ఈక్వల్గా ఉన్నాయి చూడండి రేడియస్లు. సో అందుకే ఈక్వి ఆర్ బైకాన్కేవ్ లెన్స్. అలా కాకుండా ఎలా ఉందనుకోండి ప్లేనో కాన్కేవ్ లెన్స్. ఇదేమంటారు దీన్ని? ప్లేనో కాన్కేవ్ lens. You can, this is, see, one radius is very straight and this is R2. This is towards the incident light. So the radius ఇటువైపు ఉంటుంది, this side. And of course this radius is taken as plane కాబట్టి infinite అయిపోతుంది. ఈ radius R2 ఇటువైపు ఉంది. So this is called as plano concave lens. Next మరో వెరైటీ ఉందండి. You can see ఇక్కడ కాన్కేవ్ ఉంది, కాన్వెక్స్ ఉంది. సో ఇక్కడ జనరల్ చూసుకుంటే దీన్ని కాన్వెక్సో కాన్కేవ్ లెన్స్. ఓకేనా? కాన్వెక్సో కాన్కేవ్. but its final behavior is again concave. Concave lens. Okay? ఇక్కడ ఏంటి concave ఉంది, convex ఉంది, but its final behavior will be like a concave lens. Concave lens అంటే తెలుసు కదా, diverging lens. Clear? So these are very very important. The final behavior మాత్రం గుర్తుపెట్టుకోండి. ఇది even though we are written as convex or concave, final behavior will be concave. Okay? Even though it is a convex or concave. ఇందాక మీరు చూడండి కాన్వెక్స్ లెన్స్లో కాన్కేవ్ కాన్వెక్స్ అని రాసాం, కాన్కేవ్ కాన్వెక్స్, కానీ ఎక్కువగా అక్కడ ఏంటి కాన్వెక్స్ లెన్స్ అనమాట. రైట్. సో దిస్ ఈజ్ హౌ యూ హ్యావ్ టు అండర్స్టాండ్ రిగార్డింగ్ ద లెన్సెస్, డిఫరెంట్ టైప్స్. నౌ అనదర్ ఇంపార్టెంట్ పాయింట్ ఇన్ దిస్ లెన్సెస్ ఈజ్ హౌ టు నో అబౌట్ ద సెంటర్ ఆఫ్ కర్వేచర్ అండ్ రేడియస్ ఆఫ్ కర్వేచర్స్ ఫర్ దిస్ కాన్వెక్స్ అండ్ concave lens. Into the center of curvature and radius of curvature. For example, if you take convex lens, equi, ఇది చూడండి, ఇది optic center, this is imaginary line. Now whichever is towards the incident light, that is called as R1 and this is R2. Now if you observe this carefully, the sphere, for this if you can observe, దీని స్పియర్ ఎక్కడ ఉంది, ఇటువైపు ఉంది. సో ఇట్ సెంటర్ విల్ బి దిస్ సైడ్. ఇన్ ద సేమ్ వే ఈ స్పియర్ దీని ఎక్కడ ఉంది, దీని స్పియర్ ఎక్కడ ఉంది. సో దిస్ వాట్ ఎవర్ దిస్ లెన్స్, ఈ భాగం దీని సెంటర్ ఎక్కడ, దీని సెంటర్ ఎక్కడ ఉంది. అండ్ మేక్ ఏ నోట్, ఇది ఇన్సిడెంట్ లైట్. ఇన్సిడెంట్ లైట్ వైపు along the incident light, I told you in the sign convention, taken as positive. So whichever is toward the incident light is taken as positive and opposite to the incident light is taken as negative. For example, light ఇలా ఉంది కాబట్టి దీని radius of curvature, దీని radius of curvature is taken as, this one is positive, this one. అంటే R1 is taken as positive and ఇది చూడు R2 ఇటువైపు ఉంది దీని radius against the incident light. So R2 is taken as negative. Clear? ఇది అలాగే if you go for concave, concave lens కి వెళ్ళే దాన్ని కూడా చూడండి. In the case of concave lens, you can see దీని స్పియర్ ఎక్కడ ఉంది, సెంటర్ ఎక్కడ ఉంది, దీని స్పియర్ దిస్ సైడ్ C2. సో ఇది ఫస్ట్ ఇన్సిడెంట్ అవుతుంది లైట్ వైపు. సో this one R1 is positive in this case, it is incident light, and this is taken as this, sorry, ఇది మీకు ఎలా ఉంది, లైట్ ఇటువైపు ఉంది, ఆపోజిట్ ఉంది కదా, లైట్ వైపు ఆపోజిట్, ఇది నెగిటివ్, అది పాజిటివ్ అవుతుంది. ఈ రేడియస్ చూడండి ఇటువైపు, టువర్డ్స్ లైక్ దిస్. ఓకే, సో దిస్ విల్ బి R2 is equal to positive, this one, and this one R1 is negative. Whichever is facing towards the incident light, that is negative, and along the incident light is positive. ఇక్కడ చూడండి R1 ఏమైంది, ఈ R1 చూడండి ఇటువైపు ఉంది, అలాంగ్ ది ఇన్సిడెంట్గా పాజిటివ్ రాసాం ఇక్కడ, ఇది అగైన్స్ R2 నెగిటివ్. సో హియర్ ఆల్సో if you see this one, R2 is toward this one positive, R1 is against. So like this you have to understand regarding the radius of curvature and center of curvatures for the lenses, please. Very very important, please. You have to take care of this one because in solving numericals these are very 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 important, please. Okay, and in part 5 we are almost coming to end part, that is last part. Within 5 minutes end up part 5 and remaining will go to part 6. అదేంటంటే see regarding focus, regarding focus for convex lens and concave lens. See, this is convex lens, you know, and this is the optic center. Okay, and these are radius of curvatures R1 and R2. R1 this side positive, R2 this side negative. Now some important point I want to tell you. For example, Convex and concave has two focuses. First focus and second focus. And first focus is not so important. ఒకసారి చూద్దాం ఏంటనేది. Suppose light is coming in this fashion. After incident you can see it is going parallel. Okay? It is going parallel. So this one is called as first focus. It is not so familiar, but I have to tell, that's what I am telling. This is first focus. So when light rays after meeting, it is going parallel. First focus. But second focus ఏంటి చూడండి ఒకసారి. Second focus అంటే ఏం లేదు. Same lens again. Suppose light is coming parallel like this. So when these rays meet at a point, parallel rays, at one point, this is called as second focus. Parallel light rays అన్ని ఒక దగ్గర కన్వర్జ్ అవుతాయి. That is called as second focus. Okay na? And make a note, second focus and the focal length, whatever this is called as focal length, second focus is always a positive convex lens. అలాగే మిర్రర్స్ చూడండి, కాన్వెక్స్ మిర్రర్కి ఫోకల్ లెంత్ ఏంటి వచ్చింది? పాజిటివ్. కాన్వెక్స్ మిర్రర్, రేడియస్ ఆఫ్ కర్వేచర్ టువర్డ్స్ ద లైట్. సో కాన్వెక్స్ మిర్రర్, కాన్వెక్స్ లెన్స్, ఫోకల్ లెంత్ is positive. Okay? Next one. Concave కూడా మీరు చూడండి ఒకసారి. Concave. This is the optic center. O. For example, see light rays, for example, they are meeting like this. Okay? So here this is called as first focus. This is called as first focus in concave lens. అదే విధంగా if suppose the parallel light rays are coming like this, after meeting it diverges, and these diverging rays never meet, therefore extend. So this is second focus. This is second focus. Not only that, the second focus for concave is a what? Negative. Focus is negative or focal length. అదే విధంగా కాన్కేవ్ మిర్రర్ కూడా మీరు అబ్జర్వ్ చేయండి. కాన్కేవ్ మిర్రర్ ఓకేనా? లైక్ దిస్ ఆర్ లైక్ దిస్. ఓకేనా? If you observe concave mirror, see, center ఇటువైపు ఉంటుంది. సో రేడియస్ ఏంటిది? నెగిటివ్. రేడియస్ నెగిటివే, ఫోకల్ లెంత్ కూడా నెగిటివే. సో కాన్కేవ్ మిర్రర్, కాన్కేవ్ లెన్స్. కాన్కేవ్ మిర్రర్, కాన్కేవ్ లెన్స్, ఫోకల్ లెంత్ నెగిటివ్. అలాగే కాన్వెక్స్ మిర్రర్, కాన్వెక్స్ లెన్స్, ఫోకల్ లెంత్ పాజిటివ్. సో లైక్ దిస్ you have to remember, these are very, very, very important. First focus, but maximum first focus we won't consider. Okay, mainly we'll be dealing about the second focus only in convex or concave lenses. Please, only for explanation purpose I am telling first focus and second focus, but during numericals or other things, maximum second focus kuncha manu chavatam. Okay na? And I think we'll end up here. Next part lo part 6 of reoptics, we will be dealing about lens maker's formula, that is 1 by f is equal to mu lens by mu media, లేదా simply mu minus 1 into 1 by r1 minus 1 by r2. సో ఇది డెరివేషన్ మనకు అవసరం లేదు, ఎందుకంటే మెయిన్లీ వీఆర్ డూయింగ్ ఫర్ ఎంసెట్ అండ్ నీట్ ఎగ్జామినేషన్స్ దీస్ వీడియోస్. సో డెరివేషన్స్ మీకు కావాలంటే బై యూజింగ్ జామెట్రీ కెన్ డెరైవ్. సో మెయిన్లీ ఆ ఫార్ములా ఎలా వస్తుంది, ఏ మెథడ్లో చేసి వస్తుంది అది చూద్దాం. దాని తర్వాత విల్ బి గోయింగ్ టు ద నెక్స్ట్ పార్ట్ ఆఫ్ ద థింగ్స్ ఇన్ దిస్ వాట్ ఎవర్ లెఫ్ట్ ఓవర్, దట్ ఈస్ different types of devices, that is simple microscope, compound microscope, and also reflecting and refracting telescopes. Okay na? Adi will try to end up in next 2 parts or 3 parts of the light. So we'll see in the next part remaining the lens maker formula. Okay.